is day 5 of your STAAR review, and today we will be talking about the Pythagorean Theorem. So going into your STAAR review foldable, again, you should have pasted your the Pythagorean Theorem foldable on page 4, and this is going to be this entire page here. So we're going to go ahead and first start off by looking here at these two things on your foldable. So going here, it says the Pythagorean Theorem, label ABC, the right angle, legs, and the hypotenuse. So remember, the Pythagorean Theorem is used to find the unknown length or side of a right triangle. So we do, the formula for it is a squared plus b squared equals c squared. So on this triangle, we first want to start off by labeling our 90-degree angle. And from that 90-degree angle, we always draw an arrow diagonally to it because this points to your hypotenuse. Now, the other two sides of your triangle, the ones that attach to your 90-degree angle, are called the legs of your triangle. So next, you also have to label A, B, and C. So looking at this triangle, we like to think of this as the height of our triangle. So this is our altitude, or our A. Then this would be the base of our triangle, or B. And then for the hypotenuse, we label this as C. Now remember, this also happens to be the longest side of your a right triangle. So that being said, this is everything you should have written down for this on your foldable. This is everything you should have written down. Okay, so then we're going to go ahead and get into example number 1. So example 1 says, Julian baked 3 different sized square pans of brownies by arranging them so their corners touched as shown. He found they formed a right triangle in the middle. If Julian cuts congruent square brownies in each pan without any partial pieces made by doing so, which statement is correct? Now, remember, when we square the sides of our right triangles, they create squares. Now, since they create a right triangle, when we add the areas of our 2 smaller pans, it should equal the area of our largest pan. So, in this statement, or for this, we would like to add the areas of our largest pan, and it would equal the area of, we want to add the area of our smaller pans, and it would equal the area of our biggest pan. So this means that B plus A equals C. So looking at our answer choices, it says the number of cut brownies in pan B will be equal to the number in pan C. That's not true, because in order to for it to equal pan C, you still have to add the area of pan A. So A is not true. Then we have B. It says the number of cut brownies in pan B will be equal to the number of brownies in pan C plus the number in pan A. Now, if you remember, in order to find the amount of brownies in pan C, you have to add the amount of brownies in pan B and pan A. So here, since I'm trying to find the amount of brownies in pan B, I'm trying to just find the amount in this square. I would subtract the amount of brownies from I would subtract pan A from pan C, and that would give me the amount of brownies in pan B. So for pan B, the number of cut brownies in pan B will be equal to the number of brownies in pan C plus the number in pan A. That is incorrect, because pan C alone has more brownies than pan B. So if I were to add the amount of brownies from pan A to pan C, I would still have a lot more than pan B. Then pan C says the number of cut brownies in pan B will be equal to the number in pan C minus the number in pan A. That is true. So here C is my answer. So now let's look at number 2. It says a side view of a recycling bin lid is diagrammed below, where 2 panels come together at a right angle. So given this information, how wide is the recycling bin in inches? So the first thing we want to do is look at our 90-degree angle and draw our arrow to our hypotenuse. So this is my C value. So this means that this should be my longest side. So I'm finding the length of my hypotenuse using the Pythagorean theorem, which again was a squared plus b squared equals c squared. Now when it comes to labeling your other two sides, they can either be labeled as a or b. Remember, they are interchangeable. For this instance, I'm going to label 24 as a and b as 25. So for a squared, we have 24 squared plus b squared is 45 squared, and this equals c squared. So in our calculator, we want to go ahead and do 24 squared. We want to simplify our exponents. So 24 squared is 576 plus 45 squared, and 45 squared equals 2025. So plus 2025, and this should equal c squared. Now I need to combine these two, so 576 plus 2025 equals 2,601. So my c value, right now, it is being squared. So whenever my c value is squared, I get 2,601. So since I don't want it to be squared, I need to take the inverse operation of squaring it, which is to take the square root. So taking the square root of 2,601, you get 51. So here, c equals 51. So your 1 will go in the ones place, and your 5 will go in the tens place. And again, this is before the decimal point. So here you're going to go 5 and 1. So make sure you have all of this written down in your foldable, and again, this will be on the inside flap. Okay, so next let's go ahead and look at number 3. So it says the sail of a boat is in the shape of a right triangle. The bottom of the sail is 3 feet above the surface of the water and sticks out 6 feet from the mast. Given the dimensions in the diagram, what is the total height from the water surface to the top of the mast? So here it tells you that the beginning of the sail is 3 feet above the water. Now we want to know what the total height is from the water to the top of the mast. So we know this piece of 3, and we just need to find this height of the sail alone. So looking at my 90-degree angle here, I'm pointing my arrow to C. So they have given me my hypotenuse. And it seems like I'm going to find my altitude, my A, because they have given me B, my base, which is 6. So here I have A squared plus b squared equals c squared. So I have a squared plus, I'm just substituting my numbers, I have 6 squared, and this equals c squared, which is 10 squared. So simplifying this, I have a squared plus 6 squared is 36, and this equals 10 squared, which is 100. So taking this a step further, since I have both of my numbers on opposite sides of the equal sign, I want to subtract them. So I'm going to subtract 36 from both sides because I want to single out the a squared. This cancels out. I'm left with 100 minus 36, and that equals 64. So right now the value of a is being squared to where it equals 64. So taking the square root of 64 on both sides, I have I'm going to put this in my calculator. So the square root of 64 equals 8. So here a equals 8. So the height of my sail is 8. But again, I want to know the height from the sail, from the top of the mast to the water. So I would add 8 plus 3 together, and I would get 11. 8 plus 3 is 11. So here, B is my answer. Okay, let's go ahead and look at our next example. So it says, which of the following could represent the unit side lengths of a right triangle? So, here, remember that the longest side is your hypotenuse. So given 3 angle measurements here, I'm trying to see if they create a right triangle. So I'm going to circle my longest side because those are my hypotenuses. So here I have 8, 8, and 16. So 8 will be A, 8 will be B, and then 16 will be C. So again, we're going to be plugging these into the formula a squared plus b squared equals c squared. once we have plugged in these numbers into the formula, we want to make sure both sides equal each other. If they equal each other, then those numbers are an example of the Pythagorean theorem, and if they do not equal each other, they are not. So looking at answer choice A, we have 8 squared plus b squared is 8 squared equals c squared, which is 16 squared. So simplifying my exponents, 8 squared is 64 plus 64 equals 16 squared. So putting 16 squared in my calculator, we get 256. So again, we want to simplify this. So 64 plus 64, we get 128. Now here, 128 does not equal 256. So this is not an example of the Pythagorean theorem. Then we have example B. So again, 5 would be my hypotenuse because it would be my longest side. And then we'll just go ahead and label 2 as A and 4 as B. So for B, I have 2 squared, which is A, plus 4 squared, which is B squared, and this equals C squared, which is 5 squared. So simplifying this, we have 2 squared, which is 4, plus 4 squared, which is 16, and 5 squared, which is 25. Now, if you don't know your squares off the top of your head, again, you can put these in your calculator. So we have 4 plus 16, which equals 20, and 20 does not equal 25. So B is also not an example of the Pythagorean theorem. Then we have C. So again, 36 would be our C, 12 would be A, and 24 would be B. So for A squared, we have 12 squared, plus B squared, we have 24 squared, and this equals C, which is 36 squared. So going ahead and simplifying this, 12 squared is 144, plus 24 squared, I don't know that off the top of my head. So 24 squared is 576, so 144 plus 576 equals 36 squared, which is 1296. So we want to simplify this. So 144 plus 576 equals 720. Now 720 does not equal 1296, so this is not an example of the Pythagorean theorem. Lastly, we have D. So 17 would be our hypotenuse. It's our longest side, so that's going to be C. Then between 8 and 15, we have A and B. Now for D, we have 8 squared plus 15 squared equals C squared, which is 17 squared. So 8 squared equals 64. Plus 15 squared in our calculator will give us 225. And then we have 17 squared, which I believe is 289. So now we just want to make sure this side equals this side. So 64 plus 225, does it equal 289? It does. So both sides equal each other. So yes, this is an example of the Pythagorean theorem. So just to catch us up to speed here, from examples 1 through 4, looking at your foldable here, this is everything you should have written down. So you should have this written down, and then for example 1, you should have all of that. For example 2, that's what you should have written down, and on the inside flap, you should show your work on how you got your answer. For number 3, you should have that circled on the outside flap, and then again, just have all of this written down inside the flap. And then lastly, for example 4, this is everything you should have written down. So lastly, we're going to go ahead and talk about number 5. So number 5, we have 2 points on a graph, and we are trying to find the hypotenuse here. So it says point N is located at -6, -3. So here's point N, and it tells us we translate it 12 units to the right. So we're moving this point 12 units to the right. So this is 12. And then we're going up 8 units. So this is N prime. So this is our new and this was our old. So instead of having to go, it tells me to find the closest distance between point N and point N prime. So instead of having to go all the way around, I would walk 20 units. I can cut across here, and using the Pythagorean theorem, I can find this distance. So again, the Pythagorean theorem was a squared plus b squared equals c squared. And I can only do this because this creates a 90-degree angle. And again, I point my arrow diagonally to my hypotenuse. So this happens to be what I'm looking for. So my A is my altitude, so 8 is my altitude. And then I have B as my base, so 12 is B. Now I just want to plug in my numbers. So I have A squared, which is 8 squared, plus B squared, which is 12 squared. And this equals C squared. So simplifying this, I have 8 squared equals 64, plus 12 squared equals 144, and this equals C squared. So 64 plus 144 in our calculators equals 208. So now my answer is not 208. Right now the value of C is being squared to where it equals 208. So to find the value of C, I'm going to take the inverse operation and I'm going to take the square root on both sides. So taking the square root of 208, we get 14.4. So here C equals 14.4. So now going down to my answer choices, we want to pick the closest one to 14.4, which means H is my answer.